So today we're going to talk about one big concept, and that is mixtures. Okay, but to get there, we've got to give a little definition or reminder about the states of matter. There are three main states of matter: solid, liquid, and gas. What's the fourth state that counts sometimes, doesn't count sometimes? Plasma. Okay. We don't talk about plasma. Plasma happens in really extreme scenarios. So really extreme ends of pressure and temperature, okay, which is just not what we deal with. So we're going to look at solids, liquids, and gas, okay? Here's our three states of matter, okay, and we're applying them to water. I want you to tell me what are some things you notice about the ice stage, or what would we call the ice stage? Solid, liquid, or gas? Solid. Okay, what do you notice about it? Yeah, Lily. They're all bonded together, agreed. What else? Is it chaotic?
No.
It's very ordered. It's very organized, very ordered. So in the solid state, it's extremely ordered, okay? And it's fixed. You'll hear that word fixed. It has a fixed volume and a fixed shape. That's the word I'm looking for, right? Same shape, same volume. It is fixed. And actually, in these types of molecules, we're going to get what's called a lattice, a crystal lattice. Do you know what the word lattice means? What does it make you think of? What's the word lattice make me think of? Yeah, do it again.
The pie, thing on top of a pie.
Okay, true, right. Things on top of a pie. Things like the fencing that goes under your deck. You know, that crisscross fencing, that's called lattice fencing. It's like a grid, right? That's really what a lattice is. And so as we start looking at these water molecules or ionic compounds in general, they start to form what we call a lattice. And it's essentially just a grid. It's a fixed grid. And it has to do with the positives of one and the negatives of the other attracting each other and holding it in place. Okay? So that's the solid movement. What about liquid? What do you see there? A little bit more what? A little bit more chaos, a little bit more freedom. Right? They have the ability to flow. So are those molecules still connected? They are. They are. Not all of them. I should have said it like that. Not all of them, right? Because that would mean they're solid. But a lot of them are still connected because what does water have really more than any other liquid substance or than a lot of other liquid substances? Remember what water has when it kind of forms that bubble? What causes that? Surface tension. Surface tension. And surface tension is due to the forces between those molecules. So there is still forces. That's what causes water to flow, right? Instead of just drip, 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 right? Instead of a million drips, it flows because those molecules are still connected, right? Not all of them, but some of them. And then what about in the gas stage or the steam for water? What do you think?
Floating around.
Super chaotic, right? And at that point, most of the molecules are not connected, right? They are on their own. Do you know how gas particles move? They bounce off of everything. Do they move in curved lines? Nope. They move in straight line paths. Okay? They move in rapid, continuous, random motion, but it's straight line motion. That has to do with Newton's first law, called the law of inertia. Yes. The law of inertia. Have you heard that word before? The law of inertia says an object in motion stays in motion. An object in motion stays in motion until an outside force acts on it. So these particles are moving in a straight line until what happens? Until it hits something. What something could it hit? Two main options. What could it hit? The wall of the container and another molecule, right? Those are our two main options, right? It's going to hit another molecule or it's going to hit the wall. That would cause it to redirect, right? All right, we'll talk more about gas particles a little bit later. But those are our three types of... How do I get from here to here? How do I get from solid to liquid? I heat it up, right? I heat it up. And what causes that? What does heat do? Tell me, what does heat do to get it from here to here?
It makes molecules move faster.
Agreed. It makes molecules move faster. Anything to add there? That was very good. Yes, that's right. It adds energy to the system. So let's think, if these are two water molecules and they're bonded, right? They have an intermolecular force that keeps them together. And we add energy, those molecules start moving faster and faster and faster until that bond breaks. And now they're free to move on their own. The same thing happens from liquid to gas, right? The particles move faster and faster and faster. And in water, what do they actually do? What's it called? When it goes from liquid to gas, what's that called? You do it before supper time on the stove. How does the water get from liquid? Yeah. Evaporation, good. Even simpler, it boils, right? It boils. They move faster and faster and faster. The bubbles form, right? A bubble is actually a trapped gas bubble, right? It's little water molecules, it's steam right there. So it's coming up through there. So I want to make sure we understand the process of solid to gas. It has to involve heat, and it has to do with motion of those molecules until they move so fast then they break. Okay, let's get to mixtures. That's what I want to talk about today because tomorrow types of stuff, okay, are types of matter. Solids are rigid. What's that mean? What's another word for rigid? Firm, stiff, set, right? All of those things. It has a fixed shape and a fixed volume. So if I take a wooden block and I dump it into a bathtub, is it going to still be a wooden block?
Yes.
Yeah, it's still going to be that shape, isn't it? Right? And is it going to get bigger or smaller? I don't think so, right? Its volume is not going to change and its shape is not going to. Okay? A liquid has a definite volume but no definite shape. So it takes the shape of whatever container it's in. So if I take a 2-liter bottle of something and I dump it into the bathtub, is it going to keep its 2-liter shape? You know what I'm saying? The shape of the 2-liter bottle, when I dump it in there, is it going to sit like that? No, what's it going to do? It's gonna fill up the bathtub. It's gonna fill the shape of its container. But will it still be 2 liters?
Yes.
Yes, it will. Right? It will still be 2 liters. It'll be in the bathtub shape. Right? It assumes the shape of its container. All this is very much review, isn't it? Yes. Gases have no fixed volume, no fixed shape. So it takes completely on the shape and the size of its container. Okay? So if I have something, let's say a 2-liter bottle of a gas, and I take the lid off and I pour it into my bathtub, what's the volume now? Is it the volume of the bathtub? It's the volume of the whole entire room, isn't it?
Yeah.
The whole entire room, the whole space, right? And then its shape is literally just the shape of the room, right? That's it. Not taking on bathtub shape, it's taking on room shape. Good. That's all we need to know with our types of states of matter. We should feel pretty comfortable about that, right? Tell me this, let's go back real quick. I just want to talk real quickly about my shapes of matter. We're going to do a lab with mixtures. So we're going to do the pre-lab for it today. So let's get into mixtures a little bit. There are 2 categories of mixtures. The first one is called a homogeneous mixture. Homogeneous? Homogeneous? Okay, homogeneous, or the prefix homo means the same. So when we talk about a homogeneous mixture, it means it's the same throughout. The whole mixture. Everything looks the same. Okay, there's no distinguishable parts. Visibly indistinguishable. That means I can't pick out parts and pieces. Okay? On the flip side of that, there's something called a heterogeneous mixture, and it does have really distinct parts and pieces. I'm able to pick those things out. I'm able to pick those things out. So I want to, with the person next to you, or a group of 3, if you're on your own, that's fine. I want you to come up with 3 of each, like household things that are homogeneous mixtures and that are heterogeneous mixtures. Okay, just things around your home, things in your life that you would consider homogeneous and heterogeneous. Let's see if we can come up with 3 in each group, and then we'll make a list up here. Couple minutes. No. Why is water not a homogeneous mixture? It's not a mixture. It's called a pure substance. Pure substance. But what could, maybe Jose meant this. What could be a mixture? A lemon water, even tap water. Right? When we say water, we're thinking, in chemistry, when we say water, we're thinking pure H2O. But the water that comes out of our faucets, what's it probably have in there?
Dirt.
Okay, hopefully not dirt. I'm making minerals. You know how they add like fluoride to the water, or there's minerals that filter in. That is tap water. So I'll give it to you, Jose. But we have to put tap water. Tap water, not pure water. What do you think, Creed? Bread. Okay. Okay, I'll give you that. Not the crust, just the inside.
Well,
Crust.
like whole wheat, even like
Yeah, true. Wheat bread or raisin bread, that would be heterogeneous, right? Regular sandwich white, I'll give you there. Yeah. A smoothie, good. It has to be what? Super blended, right? Super blended. Because if there's bits of blueberry or ice or whatever I can pick out, then no good. But if it's super blended, we'll put that. Blended. Super blended. Okay. What else, Jose?
Vanilla ice cream.
Vanilla ice cream. Yeah, I would agree. I can't write today. Okay. What else? You guys are coming up with really extreme examples.
Lemonade.
Yes, thank you. Lemonade is usually the first one I get, but yes. Lemonade, soda, milk, all of those types of things would be considered homogeneous mixtures. What about cleaners? Like Windex, all those types of cleaners would be homogeneous. Makeup, lotion, shampoo, all of those things are homogeneous mixtures. Okay, what about heterogeneous mixtures? Can you raise your hand? What did we have? Yeah, go, Lily.
Salad.
A salad, good. What else? Eleanor. Laundry, yep. Kyle, go.
a chocolate chip cookie.
Chocolate chip cookie. Good. Oatmeal raisin also. I think you have a